Hey guys, and welcome back to another YouTube video. Today I'm going to be teaching you neural networking from scratch in Python using the module Tensorflow. We are going to be going over the steps of how you would create a complete neural networking project, where we are also going to be looking at how we can create convolutional networks with a great deal of accuracy. You should not be having any prior knowledge about TensorFlow to take this course. You can pretty much just take this course as your first class of neural networking. We are going to be going over from the absolute basics to loading in the custom data and creating deep convolutional networks. We are going to be creating a capstone project of a neural network all coded with our own data that will classify phones and books. Now, it is not the most interesting topic. Like, I know you all might be wanting to do something a little bit more good or bad, like, something a little bit more fun. But by taking knowledge from this one video, you will be able to implement it to several different neural networking projects in the future. So, the reason why do we use TensorFlow, like why we are using, the reason is that TensorFlow is a really good module to pursue neural networking in, and it will pretty much just like handle a lot of really complicated things for you nicely. The syntax is a little bit difficult to wrap your head around, but you'll be able to figure it out. So today I'm first going to be explaining you what a neural network actually is, because that's something that I think everybody should be knowing before creating their own neural network. So I'm just going to be opening up Microsoft Word so I can pretty much draw out a rough structure of a neural network for you guys. So I'm just going to quit the terminal so we can open it up. Okay, I don't know why it's okay. There we go. So I'm just going to create myself this new document. Now keep in mind, you should be knowing some basic Python. You cannot just like do this without the knowledge of basic Python programming, because I will be skimming over some of the parts which I will consider trivial and which I consider that you all should be knowing before taking this. Neural networks from the ground up. So first of all, what even is a neural network? Like, why is it so like something that everybody is talking about these days? Like, what does it, like, what is the thing about a neural network and machine learning that sets it apart from the classical computing that we are seeing these days? What is that? So let me explain to you. So currently I'm just gonna first represent classical computing by the letters C and C. So C. So here's the thing. In classical computing, basically what we do is we feed the computer the data, and we also feed in the computer some rules on how to classify the data. And the computer will pretty much take our data and the rules, and it will give us the prediction or the answer. Now, this is the way classical computing works. Well, neural network kind of add this spin to this. We feed in the computer the data, we feed in the computer the answers in a lot of cases sometimes, and the computer will tell us the rules on how we got the answers, and then we apply those rules to a new set of data, and then the computer gives us the answers to that. And this is how a neural network works. Now it is a bit more complicated than that, but don't worry, I'm going to be explaining you all of it. Now let me kind of like give you an analogy, an example to tell you, like, explain this in a better way. Now, let's just consider you are working for some technology company, something, and you were given a task. Like, let's just say you were working for Tesla, and let's just say Elon Musk or like some engineering guy in Tesla was like, you need to develop the like the, the smart driving car system, like the software which will drive the cars like automatically, the way Tesla actually is set apart from the classical car companies, like apart from the electric nature. So how will you actually create this self-driving car? If you actually go ahead and use classical computing, you will be needing like billions and trillions of images to actually like feed in to the computer, and you will need so many rules for classification. And here's the thing, computers are really, I would say, stringent when they are following our rules. They won't even, like, have a, like, even if the change, like there is only a change of a pixel, they won't execute that command. And that is, sometimes that's what we want, but sometimes that actually creates a huge problem. So if you would go ahead, try to do it with classical computing, you would face this problem, and it would take you months, or if not years or decades, to actually come up with such a complicated program. And probably if there was some new technology, well, your code will fail, and you will have to do it again and again and again, and it can really risk a accident. Well, at that time you wouldn't use classical computing. At that time it would prove ineffective. That time neural networks will be your best friend. That time you will be using this technology to do it. And currently, yes, Tesla and all of the companies like Google and all of these high tier companies and even Fang, all of them use this technology a lot. Like Google uses this for their auto completions. Previously they used algorithms, but with the advent of machine learning, with the growth of TensorFlow, even they realized that making an algorithm wasn't the most effective and the best thing that they could do. Even they switched to neural networking, and all the companies, and you can see all of these fan companies are actually also coming up with frameworks to help us like excel in neural networking. Like we have Facebook coming up with PyTorch, Google coming up with TensorFlow, and these two are just such popular machine learning frameworks, such popular neural networking frameworks, and they are so powerful. I just cannot stress enough. But TensorFlow is actually a little bit more superior than PyTorch in some areas, and since it can be paired with such great things like Keras, we are going to be using TensorFlow for this video. But I just want to explain you neural networking, just a bit more nicely, because right now I just explained to you why you would use a neural network, but haven't really explained a lot of the things. So basically what happens is the neural network, a really basic neural network, we are not looking at anything complex right now. It has a bunch of input which we as a programmer will feed in to the neural network. So let's just say we have these three sets of input, and then we have a bunch of hidden layers. So it is gonna be all of the cool neurons, and then we have a bunch of output. So the input will be connected to the hidden layer. So every single input layer, it's not just going to be like this will be only connected to this one or this one. It will be connected to every single node of the hidden layer, and every single node of the hidden layer will be connected to the every single node of the output layer. Now there's a catch. Now I'm just gonna call this input layer I, the hidden layer H, and the output layer O. Now here's the thing, the number of neurons in the input layer should be equal to the number of neurons in the output layer, and the number of neurons in the hidden layer can be whatever you want, like X or Y or Z, or even a Greek letter like lambda, like whatever you want. It doesn't depend, like it's all up to you. So hidden layer can be X, but whenever you're dealing with, you need to take care that the number of inputs, neurons in the input layer are equal to the number of them in the output layer. Now what happens? Now each neuron in the node or neuron, whatever you call it, has a weight and a bias, and each of those weights and biases are then sent to each of the neurons in the hidden layer, which have their own weights and biases, which are further sent to the neurons in the output layer. Now there is a lot more than that behind the hood, and to be fair, it's quite complicated to even explain because it involves the understanding of really high level mathematics, and also it's like really difficult to explain in like a beginner's video. So I'm not really gonna be diving into that, and I'm pretty sure you won't be needing to know a ton of that unless and until you actually want to master. So I'm just gonna close this. So I'm just gonna open up my terminal, and we are just gonna be now to install TensorFlow. It's literally very easy. You just go pip3 install TensorFlow. On Windows you will just type out pip and you will have your command prompt open, not your terminal window, and the Linux command will be the same as what I just did. Now what I want to do is I'm just gonna cd to my desktop, cd to my neural networks folder. I'm gonna make a directory called tutorial. Okay, I think it is nn_tutorial, cd to nn_tutorial, and now inside of this I'm just gonna make a directory. So make the dataset. So in this directory we will be having our entire dataset. So right now we will have this directory dataset. So we will just cd to dataset and clear the terminal. Now we are actually going to be creating our own dataset. So that's going to be really cool because like you will actually experience on how to do this. Now to do this you need to be having a program called Ffmpeg. On Windows, on Mac, you will just install Homebrew. Just go to Google Chrome, search for Homebrew install, and just type out brew install Ffmpeg. On Windows also, it's given on the Ffmpeg website how to do it on Windows and Linux, and I think on Linux it's the same thing. On Windows it's a little bit different, but it's pretty easy. Once you have it set up, actually just a second. Alright, so once you have it set up, just type out Ffmpeg over in your terminal window, command prompt F1 Windows, and you should just get something like this, a bunch of commands that you can just do with Ffmpeg. I'm just gonna clear it again. Now here's the thing, Ffmpeg is a software which allows us to split frames of a video file in order to give us pictures. Let me show you an example. Alright, so I'm just going to make a directory called book, cd to book, and now I'm just going to open up photo booth. Now on Windows you will open up your camera, on Linux I actually don't know what. So you can see I'm right over here, and as you can see I have a bunch of videos right over here showing a book and a phone. I have these two videos showing a book and a phone. Just take those two videos of yourself. I'm just going to open up Finder. Actually, I'm just going to minimize this window for a second. I'm gonna go to my desktop and I will navigate to this dataset folder that we have, actually the NN tutorial. So I have quite a big one, NN tutorial, and we have the dataset folder and we have book. Now what should I do here? I will simply open up my photo booth, take this entire book video, and I will add it over here, and I will minimize this, and I will simply rename this to 0. Dot. Now you can just keep whatever extension it is. For me it's MOV. Doesn't really matter. Now what I wanted to do is open up Google Chrome. Now there's this website where you can copy the command, because it's a quite a long command to actually do it. Now first of all, what I just want you to do, okay, I have a few tabs open up. I'm just gonna close a bunch of them. Alright, so now here's the thing. What I want you to do is just type out ls and see if you get your video file in the directory you have. It should be there, and please do not keep this on the desktop. That's a problem some people encounter. They keep this on the desktop and they end up having like 1,000 pictures on their desktop, and it just becomes a mess. So don't do that. Put it inside a folder wherever you want, and also make sure you aren't in the desktop and there isn't any video named the same on the desktop, or it will just end up really badly for you. So I'm just gonna search for extracting all frames of the video using Ffmpeg. I think this was it. Alright, actually no, I think I'm just going to write extract frames. I think it was this one. Alright, let me have a view. Alright, there we go. Apparently this is not it. Oh yeah, I remember, it was set on Mac, and there we go. So this in this website you will see imo.com, where it will be shown how to extract the frames. Now this will probably also work on Linux and also probably on Windows. Now I'm simply going to take this entire long command and literally just copy it. Come over here, paste it, and then I'm just going to be changing some small things about it. We will pretty much name this as the video we have made. So 0.mov, and watch what happens. So we get these bunch of pictures. We get 497 pictures extracted from the 17-second video. Isn't that great? So you can see, not only in this video we have used like an existing dataset, we have actually created our own dataset. So that's so cool, right? Now I'm just going to get rid of the video, since we don't want that clogging up our actual neural network, cause that's actually pretty bad. And I'm going to make a directory called phone, really to phone, and now I'm just going to open up my finder again, and I'm going to go to phone, and I had shot another video of myself with a phone, and I'm gonna put that right. Alright, that was bad. Okay, alright, this is not that good. Okay, I had taken this and I'm simply going to drag it over here, just as I had done before, and again just do the renaming process, and just call it 0.mov, and now I can pretty much just ls. We got 0.mov, and I am just going to run this thing again, and this time in the phone. So you can see we again get about how many pictures do we get? 327 pictures. That's so good. Okay, so we had created an entire data set in like so quickly. Like we just created it so quickly, so easily, so nicely. Like look at that, in just 18 minutes we are pretty much done with it. That's pretty good. Okay, now we just need to make the neural network, and that's so good, right? Yeah. So let me have a look at my finder. We have a book dataset which has a couple of images. That's pretty cool. Now I think we will have to delete a few of them because TensorFlow is a pretty large package, and sometimes running neural networks takes some exponential time. So that's a cool thing. Now I expect that you all know just some basic numpy, and even if you don't know, it's totally fine, not a big of a problem. Alright, so I'm just going to cd back to the directory, cd to you need to cd to the directory, and now I am going to be using a Jupyter lab for all of this. Now you can pretty much just code in your basic Visual Studio Code, and you can wherever you want to do it, because the reason why I'm pretty much doing this in Jupyter Lab is because I really like the environment, and I think it's pretty cool. Now I'm just going to open it up in the Jupyter Lab. You can just go pip3 install Jupyter Lab to do it yourself. So it will open it up in Chrome. Open up a new tab and close the existing one, and you will see on the terminal it takes a second or two, I don't know why. There we go. So you can see it is running Jupyter Lab. So you should be directed to the localhost and be here, and it takes a second or two, I don't know why. It's probably because I'm recording. So I'm going to make a Python 3 notebook, and I will rename the notebook. So I'm gonna rename it as the main neural network. Alright, so you can see this is kind of the interface. Now you can go ahead and change its theme. It's all up to you, whatever. So let's just get started. Now we need to import TensorFlow as TF. Now in case if you could not install TensorFlow, you can use a Google Collaboratory. Just go up top and open up a Google Collaboratory, just search that and open it up and do it over there, and upload your notebook over there. Now then we will need a lot of modules from TensorFlow. Actually I'm just going to copy this, import, paste it over here, import Keras. Now Keras is a higher level API of TensorFlow that will pretty much allow you to ease your process of creating a neural network. Now we will need to import from matplotlib import pyplot as plt. What is matplotlib? What is pyplot? Matplotlib and pyplot are two data science libraries of Python which will allow you to plot graphs and do data science applications. You don't need to know that to take this tutorial. It's not pre-installed. pip3 install matplotlib and also pip3 install numpy. Import numpy as np, and we will need a few more modules. We need to import os, and from tensorflow.keras.preprocessing.image, we need to import this module called the image data generator, and then we need to install one more module from tensorflow.keras.pre. I'm just going to copy this and paste it right here. Import image. Okay, I'm just going to do this, and there we go. We got all of our imports. Now if you are working in a Google Collaboratory, go to settings, change runtime type, and select a hardware accelerator of a GPU. You literally get a free GPU access, so that's pretty good. Okay, it looks like we have run into a syntax error. Import numpy. Alright, this has to be as np. Yeah, I don't know why it's taking a second, whatever. So now we are going to be doing the data rep, and I'm just going to make a new comment over here. Imports. Just you can just comment up. So in case if you are going to be reading this code after a few months or years, you will actually understand what is going on. So now we just have a train_img is equals to image data generator. We grab the rescale and we pretty much just rescale the image by 255.0. It's as simple as this, and we can just no, let's get rid of that and run this. Now we can go ahead and I am sorry, right now we haven't really loaded in any dataset. We have just said that if we have an image, we want to rescale it and right away, since we don't want all of those large images logging up. So we actually need to load in this dataset. We actually need to load in this dataset that we have. and it's fortunately for us it's pretty simple. I'm going to run this. Alright, so loading in the dataset. We can just call it train underscore dataset is equals to train underscore img dot flow from directory, and then we just need to put in the path to the dataset. Now do not go into any of the folders. You want to paste the root path, so just click over here, click on copy the path, paste here. Alright, that's not what you want to do. Copy path, go over here, paste it. Now you want to specify a target size. Now you don't want all of the images to be of a different size because the model will just get confused, so we specify a target size. And the target size we want is 150 by 150. Let's just go with that. Then we specify a batch size. So we just load in a specific number of images at a time. So that's what a batch size means. Batch size, let's just go with 60, and a classification mode of binary, since we are classifying between like these two things, that is this phone and a book, so that's why. So we can pretty much just run this, and you will see it says found 967 images belonging to 2 classes. Now you should get this, you should get found whatever x number of images belonging to 2 classes, or if we are making some other neural network, the number of subfolders inside of the main folders, that should be the number of classes. Okay, now we need to get the class indices. What are the class indices? Now each like the computer interprets the book as like a number and the phone as a number. It's not like the binary, but that's how the computer represents it. Now I actually know how the computer basically does it. The computer will like the first directory of like all of these subdirectories will be labeled as 0 and following, so 1 2 3 4 5 6 7 8 9 10 and so on. Now so I know what it is, but just for the sake of simplicity I'm just going to be getting the class indices. So we can just type out print train underscore dataset dot class underscore indices, and we can run it, and there we go. We get book as 0. We get a dictionary of the indices. So book is referred as 0 and phone is referred as 1. Now we can finally go ahead and making the model. Now the model that we are going to be making is not the one that I explained to you before. We are going to be making a convolutional neural network. So what do you mean by a convolutional neural network? Well, that's a long story, but don't worry, I will explain to you what it is. Now keep in mind, this will be a little bit difficult to wrap your heads around with for the first time, but the key element to getting good at neural networking is practicing. I myself have practiced countless neural networks, and that's how I got good at it. There are many YouTube channels out there. Even my own YouTube channel has so many neural networking tutorials on it. So you know, so I'm just going to create this new Word document where I'm going to be showing you what a convolutional neural network is. So a convolutional neural network has convolutions. Duh. So what is a convolution? So convolution basically consists of two things. It consists of this big grid called the kernel and these teeny tiny grids called the filters. Now I need to give a shout out to the YouTube creator Deep Lizard, because it was from her video I actually understood convolutional neural networking, and I just wanted to give the YouTuber a shout out. Now here's the thing, the kernel has a bunch of values. Like the kernel pretty much is put on top of the image, and the kernel is divided into these cells, and the number of cells we decide how many we want in the kernel, and each of the cell is given a random value. And what we do is we take a filter whose size we specify, a 3x3 filter, and each of this is also given a random value. So x, y, and let's just take this guy as z, So what we do is we take the entire filter, we put it on top of the kernel like this, and we calculate the dot product of it, and then we will probably get like a bunch of numbers. Like let's just say we get like 1 comma 3.5 commas 10.3, whatever we get, these numbers will be stored in a confusion matrix, and that confusion matrix is basically going to resemble a pattern that the model will have found in the image, therefore making the model much more better. So I'm just going to close this and don't save it, obviously, because our drawing is not the best. So we just type out model is equals to keras dot sequential, and then we pretty much put these parentheses and the square brackets, and inside we can add our layers. So keras dot layers dot conv2d, so the convolutional 2D layer with a 64 kernel size and a 3x3 filter, and then activation function of rel. Now the activation functions are really complicated to understand and probably be beyond the scope of this one video. Now we will max spool this convolutional layer. Now I'm just going to be explaining you what a max spooling layer is, pretty like superficially, but like enough to understand what is going on. If you want to really understand max spooling at a really deep level, I would recommend that you look at the Google Open Meet, where a bunch of like the two really I would say skilled Google artificial intelligence engineers talked about these layers and other things. Like in case you want to know the names, we had Lawrence, I am Rooney, and I think one more person. So that was a really cool like video from where I actually learned this. Sorry for the phone call. So that was a cool thing from where I learned. So then the like the max spooling layer, basically what it does is it will take the confusion matrix of the convolutional layer and it will throw away these many filters. It will divide it by 2, and that is pretty much what a max spooling layer does. So if the convolutional layer is like 64 by 64 and does that, and then the max spooling layer will make it 32 by 32. So we can pretty much just copy this one line of code. I will add this comma over here. We can copy it, paste it, paste it. So we have 3 convolutions, each with a max spooling layer, and that is something we do. Artificial intelligence engineers often do is add many convolutional and max spooling layers. Now don't take it like you just need to be adding convolutional layers. No, it should depend on what data you are using. You can't just go over stacking convolutional layers. So let's just make this one a 32 kernel, and then we can all just pass this to a flattened layer and pass this through a dense layer. Now the dense layer is what I had explained to you the first time. That's basically called a dense layer, and a dense layer will have 2 neurons and an activation function of softmax. Now dense, now 2 neurons, because the number of layers in the input and the output layer should be same as we looked over here. So the book is 0, phone is 1. We have 2 classes and therefore 2 layers. We can run this. Now we are going to be going over compiling the model. Now over here the code that I will write will be pretty complicated, but wait for a second, I will explain to you in just a bit. So I'll just type out model.compile, then I'll just write out optimizer equals to Adam, loss is equals to sparse categorical entropy, and metrics will be accuracy. Alright, and then we can just go fitting the model dot fit train underscore data set and epochs epochs is equals to 5, batch size equals to 60. Alright, what did I just write here? Like optimizer, loss function, and all of that. Epochs. Optimizer basically, now let me first explain to you what an epoch is. So the epoch is basically the number of times we show the computer the data before testing it. So in this case we show the computer 5 times. Now what the optimizer does is that it looks at the loss, so the loss of the model and the accuracy of the model over the last epoch, and it will try to improve it. So that's what an optimizer does. Now sometimes it backfires and it makes it worse, but that's a different story. And batch size is something that I had already explained. So let's just run this program, see what happens. Now I'm just going to be writing a comment, getting a summary on the model. To do that we just type on model.summary. Now you can see currently the estimated time for a single epoch to run is kind of like 1 minute 28 seconds. So it should take about 5 minutes to run this entire thing. Now I want to tell you some important things. In case if you are going to be running GPU, NVIDIA 1050 Ti or higher on your computer, so if you are running a pretty good GPU on your computer, you can actually install Tensorflow Gpu, which will run all of this like significantly faster. And when I say significantly, I mean like this 1 minute will be done in like seconds. So it will run significantly faster. And if you are running like this Titan RTX or 3090 Ti, it will just be light speed. So if you are running like some really good computer, that's going to benefit you. It won't benefit the accuracy. That's like a common misconception that I've seen is that like you can only get a high accuracy model if you are running like a awesome PC. No, that's not how it works. The computation time will be reduced significantly. I'm not gonna lie about that thing, but the accuracy will not change. That just depends on the model that you are currently using. So don't be mistaken. Now one thing that I want you to note is currently, as you can see, we have a loss of about 65% and an accuracy of about 62%, and that will increase with the time. Now here's the thing, all of this that we are getting, it's on the training data, it's not on the testing data. Now you might be saying, what difference does it make? Well, the difference that it makes is that the training data is like the data that the computer has already seen while loading in the dataset, doing the processing, and obviously all the 5 times over here. Now you might be saying that, okay, so what's the big deal in it? Now the problem is, and the big deal is, that computers are awesome at remembering information. So training and testing a computer on the data it has actually seen on already is worthless. Now this is a homework exercise for you guys, is you create another folder, not inside here, just another folder like the dataset outside in the root directory, and that also should have these 2 folders of phone and book with different images, and that should be your evaluation data. So that data will pretty much test the model. It will show if the model is accurate enough on the testing data. Okay, so that's something you really want to do. The reason why I'm not doing it right now is it's just because it's like an exercise to you guys. So currently, as you can see, we are on the second epoch of the 5 epochs, and we are running accuracy of 82% and a loss of 41%. Now here's the problem, we are running a high accuracy, the loss is, it's a mere loss, but as you can see, we are actually doing a lot better. So here's the thing, we are actually running such a good model. We are having a convolutional, going through a max pooling. So you will see, when we actually get the summary on the model, you will see that first the image will be a really big kind of like having a really big shape, but by the time it will reach through the last max pooling and the flatten, you will see that the shape will have reduced because it will have gone through many max poolings. And if you don't know what the max pooling is, I explained to you when I was making the model. Now you can add different layers called an average pooling, which does something else. I actually don't know that. So you can have a look at average pooling layers, but max poolings really do the trick. Now one thing that you need to note before while using a convolutional layer, the image should have a number of dimensions of 4. You cannot have a 3 or 2 dimensional image to do the convolutional layer. So if you are running on a TensorFlow dataset, which are a type of dataset, so the pre-made datasets of TensorFlow, you will have to rescale the data using NumPy, using np.reshape, because otherwise it won't work. So you want to take care of that. So alright, let's actually go ahead and look at the predictions. So what I'm going to do is go up to my Finder, go to NN tutorial, and go to dataset, and I'm just going to go to book, and I'm just going to take this and just take these few images, and I will go over here and create a new folder, and I'm just gonna call it testing. And then inside of over here, instead of making like any sub folders, I simply paste these images. And I'm also going to go to my dataset, to go to my phone, and get a few phone images. So let's just get these 3 images, and I can simply paste them over here and test it. So as you can see, we have a bunch of images that we can test our model on, which I will show you right now. So what we can do is we can finally first load in our model. So we just type out _path, and then we can specify the path to the testing directory. So in this case it's just testing, since we are in the same directory. So if I just click on copy path and paste it here, you can see it is the same path. Then we can pretty much loop for every single file in a path. So for I in os.list I think it was list underscore dir the path, and I think I'm just going to go pass for now, and because I actually want to see if it is list underscore dir or list dir, but don't worry, I think this is correct. So we want to load in an image, so we just type out image is equal to image.load underscore img, and we pretty much want to load in an image, so it will be referred to door underscore path, but we only want to load in like a single image of the door path. So when we do that, we can actually do it very easily. So I'm currently going to be opening up like some code out top over here, just to see if we can get all of the code like done and it is correct. So this part is a little bit tricky, so you might want to, if you don't understand anything, like, you can just leave it in the comments down below. Basically what we want to do now is we'll pretty much load in all of the data using this image dot load image function, and then we can pretty much just rescale it and call the model.predict method, which will predict the model that we have created right now. And that's actually as simple as it is. So yeah, that's pretty good. So over here we have done that. Now actually I'm just going to, what I'm going to do is create a new terminal window. Alright, I don't know why it's taking so much of time right now. Alright, so I'm just going to cd to desktop, cd to neural networks, and open up a Jupyter lab right over here, just to have a look at the code once. So alright, we did our training, and look at that, a loss of a mere 9% and an accuracy of 100%. That's pretty good. Yes, it's on the training data, but it's okay. So we are on Jupyter lab. I've just opened it up on like my root folder, just to have a look if we are having all of the code perfect. And okay, so I just have gone over here, and I'm pretty much just going to go down over here. Alright, so okay, so as I told you, I was kind of finicky on this part, so that's why I'm just pretty much copy pasting just a little bit of this code, and you can pretty much take. Alright, so I'm just going to take in like this much of the code. You can copy paste it by yourself. Yeah, just this much. So basically what I've done is I'm loading the image and reshaping it to 150 by 150. Then I'm just using matplotlib to show them it's a plt.im show, and we call the image. Then we do plt.colorbar and plt.show, as you will see what colorbar does. And then I've taken all of the image and just put them together in an array. And now we can pretty much just grab the image and we can have our predictions. We pretty much don't need to write any more code now, just a little bit. So we just write our prediction is equals to model.predict on the images, and then what we can do is just type out if round prediction of the zeroth and the zeroth. Actually, you know what, I'm just going to show you something. I will just go ahead and print prediction out to the screen, and I'm just going to run this thing. Alright, so you can see it is 1 0 1 0, and let me go down 0 1 0 1 1 0. What do you mean by 1 0 1 0 0 1 1 0? All of this, like what does this mean? Like what do you mean by 0 1? This corresponds to the thing. So currently 0 1 means that 0 is the book and 1 is the phone. So if this is classified as a phone, so that's correct. This is classified as a book, that's correct. So you can see that is so good. Now let's just to show you a little bit better, we can just go like if round prediction 0th 0 is equals to 0. We can go ahead and just go plt.title what was 0 again, book, and we can also go ahead and print book. And if the round of prediction of 0 0 is equals to 1, plt.title phone print phone, and we can just run it again, and would you look at that, we are all having our thing done. So right now, since we are rounding it up, you can see it kind of gets it a little bit wrong. That's because we are basically rounding it up. So if it's in point, so it just rounds up to like the thing. So that is pretty much the entire model that we have made, and you can see it's pretty good. So I hope that you all enjoyed this video. I had a lot of fun making this. So in this long video, although it was pretty long, you all have understood a lot of concepts about neural networking, and you can now build your dream image classification projects. There's a lot more to learn. Need to learn text classification, audio classification, making custom layers and keras, and a lot of really interesting and intriguing topics. I wish you all the best of luck for your future neural networking projects, and I hope that you all get a lot of knowledge and a lot of value from this tutorial. So that's it for today, guys. I really hope that you enjoyed the video. A lot of effort was taken into making this. It would be a huge help if you subscribe to the channel, and I will see you in another YouTube video.